What happens when there is no surge shaft? And millions of tons of water suddenly have nowhere to go. In the last video, you saw how a surge shaft saves the system. But what if I told you there's another device that steps in at the last second? Not to store the water, but to let it escape. Imagine this. The generator suddenly loses load. The turbine doesn't need power anymore. So the gates begin to close. But the water is still moving at full speed inside the penstock. And now it's about to crash. This is where the pressure relief valve comes in. Not quietly, not slowly, but like a panic button for the entire plant. The moment pressure rises beyond a safe limit, the PRE bursts open instantly. Instead of smashing into closed gate, the water is given a new path. It is thrown out of the system. You will often see it as a massive jet of water shooting out like a controlled explosion. But here's the part most people never notice. Why is the water released upwards? Why not back into the river? Because sending it upward does three powerful things at once. It fights gravity, which helps absorb energy. It slows the water down naturally as it rises, and most importantly, it prevents damage to surrounding structure. But if it were released back into the river, the same high pressure could destroy walls and structure. Upward discharge turns a violent force into a controlled release. But here's the truth. A PIV doesn't solve the problem, it only buys time. It protects the system from instant failure, but it cannot fully absorb the energy like a surge shaft does. So the next time you see a giant column of water shooting into the air from a hydropower plant, this is not a malfunction. That's the plant saving itself. And sometimes that one burst of water is the only thing standing between control and catastrophe.